Hi guys, so today we're going to be solving the integral for this equation. But first, you notice that the denominator degree is larger than the numerator's degree, which means we're going to have to decompose this into a partial fraction. Or rather, we're going to have to do partial fraction decomposition. So first, let us factor the denominator. This is x3 x cubed 2x squared plus 5x minus 10. I'm simply just going to factor it to be x cubed minus 2x squared plus 5x minus 10. Now, there are many ways to find the roots for a polynomial with 3 degrees. I'm just choosing to use this method. Going to be x squared, because when you factor it, it's going to be x squared, leaving it x minus 2 plus 5x minus 2. So now it's just going to be x minus 2 and x squared plus 5 plus 0. This is your answer. So now we can just factor the denominator. So it's going to be 2x squared plus x plus 5 all over x minus 2 x squared plus 5. And you will see that this is a quadratic. So the partial fraction decomposition is going to be a bit tricky. It's going to be equals to a over x minus 2. And for this one that has the quadratic, it's going to be bx plus c. That's the way. That's the form quadratic denominator take x squared plus 5. Now we just simply solve for a, b, and c. And you can just multiply both sides with x minus 2, x squared plus 5. That's the denominator. Multiply it into here. The remainder will be x minus 2. So it's going to be, actually, let's start with a. Multiply this into a. It's going to cancel this, leaving you with a x squared plus 5 plus multiply this into b. It's going to cancel this one, leaving you with bx plus c times x minus 2. Multiply it into this position is going to cancel everything here, leaving you 2x squared plus x plus 5. Now we're just going to expand this one, which will be ax squared plus 5a plus bx squared minus 2bx plus cx minus 2c. Now we're going to factorize this. That's pull together a common factor. So to a plus b, because they both have x squared plus c minus 2b x. They both have coefficient of x plus 5a minus 2c. They are both constants. Now we're going to do what we call comparing coefficients. This has x squared, this has x squared. So that's what I mean. So we're going to say a plus b is equals to 2. This has x, this has x. And the coefficient is 1. I know you can see, but it's there. To be c minus 2b equals to 1. And the last one is 5a minus 2c. This is a constant, this is also a constant. So it's equals to 5. Here we can say b is equals to 2 minus a. Now we'll just substitute it into this formula. So it will be c minus 2 times 2 minus a equals to 1. Which means here will be equals to 5 minus 2a. Now we'll substitute this into this third equation. So it will be 5a minus 2 times 5 minus 2a equals to 5. If you simplify, it's going to be 9a equals to 15, which means a is equals to 5 over 3. Now for c, you can simply say c is equals to 5 minus 2 times 5 over 3. That will be 5 over 3 itself. And then for b will be equals to 2 minus 5 over 3, which is equals to 1 over 3. So now to write the full equation is going to be 5 over 3 x minus 2 plus b 1 over 3 x plus 5 over 3 over x squared plus 5. Now we can just integrate this because this is the solved partial fraction decomposition. We differentiate with respect to dx. To make our lives easy, I'm going to separate this. It's going to be 5 over 3 x minus 2 plus it's going to be 1 over 3 x squared plus 5, and this is going to be We can just be differentiating each of them with respect to dx separately. And then the last one will be 5 over 3 x squared plus 5 with respect to dx. I'm just going to write dx here. Differentiating the first one is going to be 5 over 3, 1 over x minus 2, because this is a constant, I brought it out. The integral of a reciprocal is simply ln, so this is just going to become ln x minus 2. Yeah, for the next one, it's going to be a bit tricky. You can bring out 1 over 3 because 1 over 3 is a constant, so it will leave you with x over x squared plus 5. And this is not a reciprocal with 1 on top, so we have to use substitution method because this is a function in a function. The first function is x squared plus 5, and the second function is that it's a reciprocal x over the function, and x itself is a function. So this is a function in a function. So let u equals x squared plus 5. Du is equals to x dx. Dx will be equals to du over 2x. Substitute back into the equation, it will be, sorry, dx must be, substitute back to the equation, it will be 1 over 3 x over u times du over 2x. X is going to cancel this. Come out as 1 over 6 ln u, because it will be integral of 1 over u left. And u is what? X squared plus 5. That's it. And then for this last one is a bit tricky. So 5 over 3 comes right because it's a distinct x squared plus 5. We see this is a square, so we're going to have to use a standard integral. 1 over x squared plus a squared dx is equals to 1 over a arctan x over a. So let's put it in this kind of form. It's become 1 over x squared and root 5 square. So that means the final form will be 5 over 3 to be 1 over a, in this case is root 5 tan inverse. I don't know why I'm writing arctan x in this case is x itself, and then 5a is root 5. So this will be your answer. So the final answer for this entire equation is 5 over 3 ln x minus 2 plus 1 over 6 ln x squared plus 5 plus 5 over 3 root 5 tan inverse x over root 5 plus c, a constant. Thank you. Anything you do not understand, do not hesitate to ask in the comment section. Thank you.